Hello, I'm Aaron Hilton, the author of this real-time surface editing system produced in collaboration with Colin Bradley's research group at the University of Victoria. This program demonstrates several things: level of detail management, surface editing using shaders, editing shaders in real time, and layering of shaders to produce enhanced detail. For level of detail management, the surface editor engine uses a quad tree subdivision structure. This is where the entire surface gets split into 4 pieces, and each piece can get split again. This continues until the geometry density averages out from the user's point of view. In order to keep frame rates up, the editor tries to keep level of detail changes iterative and small. When the engine detects that the geometry is too dense or isn't visible, then it tries to find other geometry that needs additional detail and commences a balancing act. The surface editor uses a concept of shaders. Each shader can deform the basic surface geometry, apply textures, or generate additional geometry for details like grass. The editor currently supports 4 shaders. The first is a base shader which generates a spherical landscape representing the Earth's curvature and is the foundation for geometry deformation. The second is a height shader that displaces the underlying geometry and supports editing via the touchpad. The third is a simple texture shader, which lays down a basic texture map. And the fourth is a texture shader, which supports alpha blending its own texture on top of underlying textures, and supports editing via the touchpad. Surface editing should be quick and responsive, since the artist greatly benefits from immediate feedback about what they're doing. The surface editor employs a Tactex pressure imaging surface for touch input. This gives the surface editor a nice responsive feeling like clay, deforming and molding from the finger's touch. With a quick stroke of the fingers, a lot of surface can be deformed in subtle ways, much like clay. Also, a user may etch small changes by using the very tip of their fingers across the pad. To facilitate quick feedback, the engine's level of detail management is used to great effect. Since most of the data has already been decimated to just the stuff the artist actually needs feedback on, the engine can then apply the pressure pad's input onto the post level of detail surface, deforming or etching the surface in real time. When the artist releases their hand pressure from the touchpad, the engine then bakes the gathered input into the shader's high-resolution internal data. Nearly everything in the surface editing engine is considered a shader. Layering multiple shaders of different sizes give the engine great scaling flexibility, from simple little surfaces to wide open expanses. In this example, mountains are generated with the stroke of my hand, and a small H was etched into the side of the mountains as another shader.